Today we're going to talk about titration. Titration is an awesome experiment. It's an experimental process that we undergo, and you will be thrilled and excited throughout your titration. It is a process through which we determine concentration of an unknown acid with a standard. A standard base is a base of known concentration. Now, what equipment do we need? We need a pole at your lab table, so make sure that it is securely placed. Then you need a burette clamp. Notice that there are two sides for it, possibly for two burettes. In our case, we're going to use just one burette. And we're going to tighten it so that it is secure in place. The next thing you will need is a burette. The burette is an interesting piece of equipment. It has a stopcock, which allows you to open and close and even drain drop by drop. It has the scale is kind of backwards. The 0 is up here at the top, and the 50 is here at the bottom. Now, this allows you to fill it up, and as you're draining, you can tell how much of the acid or the base you have been adding. And you can accurately determine how many milliliters you have. Now, the next step would be to make sure that your burette is properly cleaned. At the end of the last titration, the students should have used a long brush, washed, put a soap and water solution, and drained into the sink the burette, and make sure that it is left clean for the next group. Pour lots of water, distilled water, first tap water, then possibly distilled water, so that it does not contain any residue whatsoever. Now, but when we're beginning that titration, we are going to assume that these have been properly washed, and all we're going to do at this time is add some distilled water using your wash bottle. And we're going to make sure that we roll it around so it goes into all of the different areas of the burette, and then we're going to drain it. And as it drains, you can check to see that it's draining properly and that it's at the same time cleaning. You may want to pour some out on the other side, roll it so that you are getting each area of the inside of the burette. Now, next thing, I am going to clamp the burette in place. I push down on these little levers, and then I clamp the burette, and it will be secure in place. The first step here is going to be to pour my base, make sure that my stopcock is closed. If I am not sure if it's been drained properly, I am going to go ahead and drain some more, which is true. I had a little bit left in there, and make sure that it's completely drained of any water at all. There may be some bubbles. Try to get rid of those, but we do the best that we can possibly do. I'm reminded that the base is what goes in there. This is a 0.5 molar solution of sodium hydroxide. So the base will go in here. Now, one thing to remember is that the base should not be left in the burette overnight, because it edges the burette, and then it starts looking kind of, it starts eating at the glass. So we don't want to leave it there, so we have to drain it at the end of each day. Now, I'm going to go ahead and pour my sodium hydroxide, my base, into my burette by using a funnel. At this point, it may be helpful to have the tallest member of your lab group to do this, and in my case I'm going to have to stretch a little bit and burette. As I get closer to the top, I'm going to slow down, and I'm going to, because I want to actually go past the 0 mark, but not too much past, because I don't want to spill it. And now I am going to have to drain a little bit so it actually flows in here and my readings will be accurate. So I'm going to drain to the 0 mark. And it would be helpful, again, somebody who can read it at eye level. I'm a little low here. I don't have a little bench here, but it's all drained through and everything's full, and now it is closed. Now, my next process is to use another beaker. We're not going to measure the acid in a beaker or a graduated cylinder. There's basically two ways to do this. You can use another burette to get an accurate reading, or you can use a pipette, such as this one. I have one now that is 5 milliliters only, but just to show you the process, I will use it, and I am going to pour some of my acid into a beaker, and I'm going to show you the proper method of pipetting. Back in the days, we used to use our mouths to pipette. We don't do that anymore. Too risky, too dangerous. We use a bulb, and we allow the bulb to just barely kiss the top of the pipette, and we're going to squeeze, and then we're going to draw the substance in, and then I'm going to stop, and I may have to do this again. Repeat the process. Okay, and now I'm going to place my finger on the top of it and drain. Move my finger gently along the top and drain until I get to the accurate reading of 0, which is where I want to be, so that I know when I drain this back in here, I am adding exactly 5 milliliters of the substance. And since I want a little more, making sure that it's all drained and out, I'm going to use 10 milliliters for this particular instance. And again, I'm going to repeat the process. Now I'm going to use a very small amount of acid. Normally we don't use such a small amount, but I'm going to use a small amount for my titration, just because I want to expedite the process. Now, the next thing I'm going to do, I'm going to add my acid-base indicator, which is the way that I'm going to tell if when the equivalence point is reached. So I'm going to add 1, 2, 3 drops of phenolphthalein, which, notice, does not show any color whatsoever in the presence of an acid. Now we're ready to start our titration process. I have a piece of white paper in order to determine the end point. It is the point at which there's a very slight pink color. Fuchsia, but very slight pink. Now, drops of phenolphthalein, swirl, and notice there is no color visible with the acid. However, at the end point, where the mole ratio is stoichiometrically correct, I will see the end point, the pink color. All right, so I'm going to go ahead and begin my process. I'm going to add gradually, and sometimes I can do this to make it go slow, and then I swirl. Try that again. That's about 1 milliliter or so, probably about a half a milliliter. Do it again. Try that again. And I know that I'm getting closer when it starts to linger, when the pink starts to linger. Very close to my end point. That was just 1 drop. I will try 1 more drop. Must go 1 drop at a time. That was 1 drop. There's one that wants to fall in there. but we're not going to let it. Ooh, not quite there. There's a half a drop that I'm going to let roll down the side there. Okay, I'm going to pull it out and see if I can get that little drop on the side. Not the best technique ever. That was one drop. And as we swirl, it gets closer to the end point where I want it. Now, at this point, I would read my burette. I know how much base, how much acid I used. I know how much base I used by reading accurately. Remember to read past the markings, one more decimal after the markings, and then we can do our calculations. Volume of the acid times the molarity of the acid equals the volume of the base times the molarity of the base. That is true for a monoprotic acid, for acids that contain only one hydrogen ion to donate. But if we have diprotic, such as H2SO4, or triprotic, such as H3PO4, we must calculate a little further. We must do more stoichiometry. We reached the end point, but let me show you what happens if you overshoot. You do not want to overshoot because at that point you do not have the equivalence point. So let me show you what can happen if I go beyond one drop or 2 drops possibly. Take a look. Just a little bit more. See what happens? That's overshot. It will not return to that pink. And if we really overshoot, then you have a much darker fuchsia color. That is not what we want for a proper titration. We want the end point. More on that in class, and happy titrating. And I will leave you with this thought. What did one titration say to the other? Let's meet at the end point. Meow.